Welcome to Spring LIB.
This is the answer to Chapter 21, problem number 74 from the Smith Organic Chemistry textbook. And this problem asks us to draw a stepwise mechanism for the conversion of this diketone into a furan. Are we told that this takes place under acidic conditions? Yeah, okay. So the problem tells us the only reagent that we're using is sulfuric acid. The first step is going to be protonation of one of these ketones. So the lone pair on the oxygen will grab a proton like that. And so our first intermediate is going to be the protonated ketone there. And so remember, for carbonyl compounds, when they are protonated like this, the rationale behind protonating them is it makes them more susceptible to nucleophilic attack at the carbonyl carbon. And so in this instance, susceptible enough that the oxygen of the other carbonyl can act as a nucleophile and add in to the carbonyl carbon of the carbonyl that we protonated in the first step. So that's going to go ahead and form our ring. That's going to look like this. So there's the oxygen. The oxygen has 3 bonds now, so of course it will have a positive charge on it. We should not forget these methyl groups. And then also this carbon is going to have the alcohol that is the residue of the carbonyl that we protonated in the first step that was then added into. So there we go. There's that. I'm actually going to draw a hydrogen there, and it will become apparent why in a moment. So there is, as I said, a plus charge on that oxygen. It has 3 bonds. In order to relieve that plus charge on the oxygen and to form the first of the double bonds in our furan, we can use the conjugate base of the sulfuric acid that we used in the first step. So it has a negative charge. This oxygen has 3 lone pairs. And one of those lone pairs is going to grab that hydrogen, and those electrons will go to form a new double bond there, and these electrons will revert to the furan oxygen. After those 3 arrows, we are going to be at this intermediate. So now this oxygen is uncharged. We have a double bond that's formed there. Still have our methyl groups here and here, of course, and then our alcohol there. The next thing that's going to happen in this mechanism is we're going to have to get rid of that alcohol. And the way to do that is, again, to use protonation by sulfuric acid, because, of course, there is still sulfuric acid floating around. So that's going to look like this. One of the lone pairs of this alcohol oxygen will grab this proton. And so this alcohol has now been protonated. So obviously there's a plus charge on that oxygen. And one thing that we should definitely know by now is that that is going to make this into a good leaving group. So alcohol is not a good leaving group. but water is a great leaving group. Um, okay, so that bond will break, that water will leave, and of course that's going to result in a carbocation being formed at the carbon to which that alcohol or water was attached. And I do apologize, I omitted a double bond there. So there it is. Okay. And so at this point, we're here, and I am just going to draw hydrogen there. And again, the reason why will become apparent momentarily. So we have a carbocation there at that carbon. And then again, we can use the conjugate base of sulfuric acid. This oxygen has a negative charge and 3 lone pairs. One of those lone pairs will grab that hydrogen. Those electrons will kick down to form a new double bond between the carbocation and that carbon. Whoa. Right. And so that is going to result in the formation of our final product. So there we go. There's our furan, the molecule that we were trying to form. And so this is a pretty straightforward mechanism. Protonation of one of the ketones so that the other one can nucleophilically attack it. Removal of a likely hydrogen by the conjugate base of sulfuric acid in order to relieve the positive charge on the furan oxygen and to form the first double bond. And then just protonation of the alcohol. That's a residue of our first ketone. Leaving of that leaving group, and then removal of a second hydrogen in order to form the second double bond. And that's the mechanism, and that's the answer to chapter 21, problem number 74.